Welcome back, geometry class. We're going to move on in the unit of triangles. Look at how close we are to being done. Holy cow. This is a beast. Anyway, today we're going to cover congruence in right triangles. So, what are we going to learn? We're going to learn one theorem, an awesome theorem called the hypotenuse leg theorem. And then what are we going to do? You guessed it, proofs. Whee! Okay, notes first. So let's take a look at the notes for this particular lesson on something called the hypotenuse leg theorem. First thing you got to understand is this little note here. Did you know only right triangles have a hypotenuse? It's the side that is opposite the right angle. So when we have a right triangle, we have a right angle. And we'll be using the definition of right triangles for these proofs because we must establish we're dealing with right triangles to use the hypotenuse leg theorem. So the way the hypotenuse leg theorem works is if you're working with a right triangle, and the hypotenuse is congruent and one of the legs are congruent, then you have congruent triangles. Okay, so there are a couple conditions. Well, three. That's more than a couple. We have conditions for that. Make sure we must be working with two right triangles. And the triangles have a congruent hypotenuse, and there is one pair of congruent corresponding legs. Okay, so that's the note. And when we use this reason for proving triangles congruent, we'll be using the hypotenuse leg theorem. And you'll see I abbreviate that later. Most people do with the old HL. But hypotenuse leg theorem. Okay, well, let's take a look at this little thing in action before we go crazy. Too crazy anyway. The first little example we have is using the hypotenuse leg theorem. Take a look at this diagram. I'm going to give you a couple bits of info. If angle ADC and angle BDC are right angles, so let's look at where they are. ADC, that's a right angle, and BDC, that's a right angle. No need for that second one, it's implied, but anyway. And AC is congruent to BC, so AC is congruent to BC, bloop, bloop. Are the two triangles congruent? Okay? Now, remember that note. If we have right triangles, we have a hypotenuse. So, do we have right triangles? Yes, we do. Okay, so we have right triangles and we have a hypotenuse. The only thing that's missing from the hypotenuse leg theorem in this example is the leg. So we have to show that we can either have DA and DB congruent, that's a leg, or like something else should be sticking right out after DC congruent to itself. So since DC is congruent to itself, bloop, bloop, reflexive property of congruence. Since we have that's the case, we have a congruent leg now. Okay, so we have the hypotenuse and the leg of a right triangle. So we have congruent triangles. So are these two triangles congruent? Yes! Yay! So yes, they are congruent. Why? Because we can establish one of the legs through the reflexive property. So you remember what we have here? Hypotenuse, and then we established one of the legs. Okay, so we have to know our way around a right triangle, knowing that the hypotenuse is the side opposite the right angle. So that's the use of the hypotenuse leg theorem. The rest is proofs. Whee! Now let's get into it, boys and girls. All right, let's jump in. Why even take a break? So we're going to use the hypotenuse leg theorem. Here's the proof. We're given that angle PRS and angle RPQ are right angles. Bloop, bloop. And we're given that SP is congruent to QR. So here's segment SP, here's congruent QR. Those are congruent. Are we dealing with two congruent triangles? Now, remember how we work with this. We must establish a game plan first. Hopefully by now you see yes, because they are totally congruent triangles. And how we know? Hypotenuse leg. Okay, because we can bust out a little bit of reflexive property going on there. We have the hypotenuse leg. But there's a method to the madness. When you're dealing with the hypotenuse leg theorem, there's a method to the madness. The first thing we have to do is establish that we're working with right triangles. Okay, we must establish that. We can't assume it in a proof. We must establish it in a proof. So we have to establish that we are working with right triangles. Once we establish we're working with right triangles, then we point out the congruence of the hypotenuse and the congruence of the leg. Okay, so once we have that, we're all set. Okay, so there's a method to the madness. So the game plan has to be, first things first, establish right triangles. Once we have that, we can then show our hypotenuses are congruent and then our legs are congruent and we're good to go. So we have to follow this method. Now, how in the world can we establish these are right triangles without looking at the picture and going, duh, right? Duh, they're right triangles. I mean, duh, they're right there. So we have to establish it. How does that work? We start with what is given. Okay, what's given to us is that we're dealing with right angles. So angle PRS and angle RPQ are right angles. That's given. What do we do with that piece of information? We can now say that the triangles are right triangles. Why? Definition of a right triangle. So that's going to be the argument we use to avoid us from saying duh. So when I say the first thing we have to do is establish right triangles, we have to start using the definition of a right triangle. Because we can't just say duh. We can't talk about a hypotenuse until we establish this. Okay, so we can't even mention the word hypotenuse until this is written. Now that we have that, we're ready to go. Now we know we're working with right triangles. The next thing we need to do is establish our hypotenuse congruent. Can we do that? Yes, it's given to us. It says that segment SP and segment QR are congruent. That's given. So we have established our hypotenuse as congruent. Okay, so first the triangle, then our hypotenuse. Now can we prove a leg? Can we establish a leg congruent? You guessed it, reflexive property. Bam! So yes, we can totally establish a leg congruent to itself. That is the reflexive property. That gives us the leg. And with that done, we can now prove the two triangles congruent by the hypotenuse-leg theorem. So remember, if we're going to use this, we have to follow a little method to our madness. Okay, we have to use the hypotenuse leg theorem, and we have to first establish right triangles. We can't just start talking about a hypotenuse without the right triangle being present. Okay, so that's a logical piece that we must use. Okay, so let's see if you can apply that to some more examples. So we're going to do examples for the rest of the notes. All right, so here's another example. Here's a neat little diagram. I have a note to the side. You'll see it in a second. All right, so given segment BE bisects segment AD at C. What? What? Slow down. I said too many things. So when you look at something like this and you can't follow it, look at the picture. BE bisects AD. Ah, so this is the bisector of this. Aha. So what this is saying now is that we can establish this is the case. We can go ahead and do that. That's what that means. BE has cut AD in half, two congruent parts. Okay? The last thing that's there is, well, the next things are AB is perpendicular to BC. All right, let me follow your eyes. AB, BC. Okay, right angles. And then DE perpendicular to EC. Okay, right angle there. And the last thing that's given is AB congruent to DE. Oh, that's, so you can see, right, the game plan. The game plan is done. You should see we have hypotenuse leg theorem in action, right? So you should see the game plan. It's there. We have the game plan. It's hypotenuse leg. But how in the world are we going to do this? Remember the method to our madness. We must first establish right triangles. We can't do anything until we establish right triangles. Then we establish our congruent hypotenuse. Then we establish our congruent leg. And we're good to go. It has to follow that logical progression. So the question is, how do we go from what's given here to right triangles? Because all that's talking about is perpendicular. Well, perpendicular leads to angles. Angles lead to triangles, right? So we have to follow that method. So this is how I'm going to start. I'm going to start with the perpendicular stuff, because the perpendicular stuff is what gives us right triangles. We have the given statements about perpendicular segments, okay? Now what do we do with that? With that, we can start talking about angles. Okay, with perpendicular, we need to start talking about angles. And what are the two angles we can talk about? angle CBA and angle CED. We can talk about those angles now, so let's do that. Okay, so angle CBA and angle CED are right angles, and that is the definition of perpendicular. So notice the progression. We went from segments to angles. And now from angles, remember, we still have to establish congruent triangles. So we're going to go from angles to triangles. Okay, so now we can say that we're dealing with right triangles. And yes, the answer is yes, kids. Yes, we must do this. Okay, so we have to establish right triangles. So we use the definition of right triangles to establish that we're working. Now we can start talking about hypotenuses and stuff. So that's the tricky part, right? Once we have that, let's start throwing out our given. BE bisects AD at C. That was the given thing, right? Remember what was given? It gave us that. We can't say CA and CD are congruent. That's not given. We have to use that note for bisects. So now we can say that CA and CD are congruent because that's what a bisector is. That is the definition of bisector. Okay, and we have to use that argument as well. That's a tricky argument. Okay. Now, the last thing is, well, what we've just done with this. What have we just done with CA and CD? We have established our hypotenuse. Okay, so we established right triangles. Now we have established our hypotenuse. All we got to do now is take care of one of the legs, and fortunately, it's given. Yay. That last little given, it was sneaky up here, right? That's a sneaky given, sneaking it in. But always look at the picture, right? When in doubt, go to the picture. You won't forget it. So the leg is given. So now we got a hypotenuse, we got a leg, bam! Hypotenuse leg theorem. We have congruent triangles. Okay, so this is a nice proof. I mean, this is tricky. But the cool thing with this proof is that this little note, this particular proof, you could also use angle, angle, side. You don't have to talk about right triangles. You could use angle, angle, side. How? Vertical angles, boys and girls. Right? If you talked about vertical angles, you could have went angle, angle, side. Right? That would have been totally legit. But we're talking about hypotenuse leg, so let's talk about hypotenuse leg. And the question might be, hey, for all hypotenuse leg proofs, can you use angle, angle, side? The answer is no. And let's take a look. Suckers. More proofs! Yay! So we got this diagram with some given stuff going on. We're going to prove these two triangles congruent. Here's an example that we cannot use angle, angle, side. Anywho, what's the method to the madness, right? We have this given state. Remember the method to the madness. We must first establish right triangles. Then we can start talking about hypotenuses, and then we can talk about legs. So we look at the diagram, and we can clearly see we got a hypotenuse going on. Is there anything else that we can establish for a leg being congruent? And then we read, segment AD is the perpendicular bisector of segment CE. Wait, what? I don't understand that. So look at the picture. Segment AD, this thing, bisects this thing, is the perpendicular bisector. So with that piece of information, that's why this is a right angle, but it does something else. Bisects. If it bisects CE, that means it cuts CE in half. That means we have this. That means we have a leg. We have a hypotenuse. We have a leg. Hypotenuse, leg. We're good. That's the game plan. The rest is the proof. Okay, the proof is in the pudding. So let's go. Remember the first things first. We must establish right triangles. So let's talk about that perpendicular situation. AD is the perpendicular bisector of CE that's given. Now, what does that mean? We're talking about segments here. We have to talk about angles so we can talk about triangles, right? Oh, I love this stuff. Anyhow, so now we can start talking about angles. If that's the case, then angle CBD and angle EBA are right angles, right? CBD and EBA are right angles. How do we know? Well, that's the definition of perpendicular, fool, right? So that's what perpendicular means. So we went from segments to angles. Now that we have angles that are right angles, guess what we have? Right triangles. And we must establish the right triangles. So we must establish it this way. Now we have our triangle. CBD and EBA are triangles, are right triangles. So once we've established that, we can start talking about hypotenuses, which we can talk about the hypotenuse first, but in this particular case, I'm going to talk about the leg first. Now, why am I going to talk about the leg first? Because we brought up the perpendicular bisector. Since we brought up the perpendicular bisector, I ain't done with it. Perpendicular bisector does something else besides give us the right angle. It bisects CE. So the perpendicular bisector gives us the congruent legs. So while I'm talking about the perpendicular bisector, I may as well establish my congruent legs. Okay, so notice that thought process. While I'm working on the given statement, let me just milk that given statement for everything it can give me, and it can give me quite a bit. Look at what that given statement has given to us. It's given a lot of information, right? So it's given us the right triangles, and it's given us congruent legs. And so I'm going to keep milking it before I bring in anything else. So I've completely milked that given statement. I'm done with it. I've got all the information I need from it. And now the other piece from that given, what was given is the hypotenuse. And so I've established right triangles. I got my leg. I got my hypotenuse. I'm done. Triangles are congruent. Now, remember that note last time from that last proof? We could have used angle, angle, side. We can't do that here. There is no angle, angle, side here. Okay, so we don't have angle, angle, side congruence. We must use hypotenuse leg. Okay, so sometimes you can get away with not using hypotenuse leg. Sometimes you can't. You have to use hypotenuse leg. So there's that. If that was too much, rewind, right? But I thought that was cool. In the meantime, let's do more proofs. Yay! Oh my God, this is so much fun. Okay, next proof. So we got some stuff going on here. And I'm not giving you any tick marks, right? So we got to read some things. So let's make the tick marks on our own. So we got given ON congruent to ML and LP congruent to PN, and angle OPN is a right angle. Blah, blah, blah. We got to prove the two triangles are congruent. So what's going on? Let's mark up some stuff. ON is congruent to ML. ON, ML. LP is congruent to PN. LP, PN. And then OPN is a right angle. Okay, there. Now, what can we do? Well, first of all, you should notice that we cannot use angle, angle, side. This is not angle, angle, side. It's not side, side, side. It's not angle, angle. It's not, we can't use any other congruent thing. We have to use hypotenuse leg. So we have to establish right triangles. We have our hypotenuses, and we have our legs. Okay, so the thinking, right, the roadmap is there, I hope. The challenge is, can we establish right triangles? So let's go. The first thing that's given is angle OPN is a right angle. Given. Well, we know that's a right triangle, right? But what about this triangle? We don't know anything about triangle MPL. So let me talk about that angle MPL. So I'm going to go ahead and say that angle MPL is a right angle. How do I know? Vertical angles are congruent. Okay, so I can know vertical angles are congruent. So if that one's right angle, that one's a right angle. Piece of cake. So now I have my two right angles. Now I can talk about my triangles. All right, so triangle OPN and triangle MPL are right triangles. Definition of right triangles. I have established right triangles. It's so important. Once establishing right triangles, well, do we have a hypotenuse? Yup. And do we have a leg? Yup. Those things were given to us, right? And so once we have our right triangles established, hypotenuse, leg, proof, done. Okay? And that's how that works. So these proofs, not too shabby there, cats. But if it was too fast, pause, rewind. The game plan is the important thing, right? Last thing is just a quick quiz, right? Quick quiz. And then we'll be done. The triangle shown below, congruent, explain yourself. So we got stuff going on here. Hopefully you can see we have right triangles, right? Hypotenuses are congruent. Guess what else is congruent? The legs, reflexive property. Bam! So yes, hypotenuse leg theorem. All right. So that's what it might look like that on a goofy state test, because state tests are goofy. Anywho, that's what a quick quiz might look like. So what did we learn in this lesson? I hope we learned right triangle congruence. I hope we learned the hypotenuse leg theorem, and I hope we got more comfortable with proofs. Run those down the unit, kids. I'll see you next time.